In order to demonstrate a while loop, I've gone ahead and created whileloop.py.
This video is brought to you by ObbyPies Academy.
The first thing we're going to do is create an iterator. That's a fancy word for counter, and that's the variable that's going to keep track of the number of times we go through the loop. So let's call that variable I for iterator, and I'm initially going to set its value at 0. Not very creative, but a good place to start. Now, the while loop lets us loop while some condition is true. So let's say the condition is I is less than 11. So what that means is every time this is evaluated as true, I is less than 11, we'll continue looping. So while I is less than 11, let's print the value of I, and let's add 1 to the value of I, keeping in mind that the right side of the assignment operator is evaluated first, so this will add 1 to I. So first time through the loop, I will be 0. 0 is less than 11 evaluates as true. We'll print the 0. We'll add 1 to 0 and assign that to I, so I is now 1. So now we test again. Is 1 less than 11? That evaluates as true. We print the value of I, and then we add 1 to the value of I, and I is now 2, and so on, until we get to the number 11. When we get to the number of 11, then 11 is less than 11 evaluates as false, and we stop looping. Now keep in mind that everything that is indented under the while statement will execute each iteration of the loop. I think we've got our complete program here, at least to start off. So I'm going to choose File and Save. And then I'm going to bring up our command line window. That's the one running idle, so let's bring up a new command line window. And let's use this to run our program. So let's move to our desktop. And inside that is the Python folder. And then this is called whileloop.py, so we'll run it with the Python command. I use tab to autocomplete there. And there we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, we didn't get 11, and this is a common source of errors when people start doing loops. It's called a one-off error because they see the 11 here. They say, oh, it's going to count to 11. But remember, when we get to that point, I is 11, 11 is less than 11, evaluates as false, so we stop looping. Now, of course, loops can do a lot more than count by 1. For example, we could create a loop that counted backwards. So let's say here we set x and we give it the value 50, and we say while x is greater than 0, we're going to print the value of x. We're going to say x equals x minus 5. So this loop is going to react a little differently. We're going to start at 50. We're going to test x is greater than 0. We're going to print the value of x and then subtract 5. So think about, do you think 0 will be included in our results for the second loop? And let's print between the two of these just a separator, just to make it visually easy to see where one loop begins and one loop ends. All right, so let's save our source code, and let's again bring up our terminal window. And let's run our program. So moving to the desktop in the Python folder. And now, let me move this so you can see the code at the same time. We should see both loops run. Python whileloop.py. So first loop, of course, does the same thing. Second loop here now subtracts 5, and the 0 is not included. Because if you think about it, when we get to 0, 0 is not greater than 0, and we immediately exit the loop. Now, with loops, there are some dangers. For example, it's really easy to create what's called an endless loop. An endless loop is a loop where the continuation condition is always true, so the loop never exits. Now, this can cause a problem because it can draw more and more resources as the number gets larger and larger. So it'll draw more and more resources from your operating system and eventually will hurt the performance of your machine. Okay, so let's go ahead and create our endless loop. For our endless loop, I'm going to set x equal to 1. And then I'm going to set a condition that says while x is greater than 0. And we'll print x, and then we'll multiply x times 2. So if you think about this, first time through x is 1. Is 1 greater than 0? That's true. So we print 1, and then we multiply it by 2. Now x is 2. Is 2 greater than 0? Yes, it is. So we print 2. Then x is 4, and so on. So if you see, there's no way to exit this particular loop, because if we try and exit, we can't exit the loop because x is always going to be greater than 0. There's no way for us to exit. All right, so let's go ahead and save this particular example. I'm going to call this endless.py, and let's watch what happens. So let's bring up our command line. And here we go. And now let's run it with endless.py. So this number is getting bigger and bigger and bigger and bigger and bigger. Now eventually this is going to draw all the available resources from my computer because this number is going to get so big it's going to become difficult to calculate. That may take a while, but you can see here if I stop this with Control C, you can see how big the number is getting. It's taking up multiple lines. Let's go ahead and print a separator here so we see each number. And let's go ahead and let's make this more fun. Let's multiply x by 9. So the number gets bigger that much more quickly. All right. So here we go. Let's run it again. You can see how quick that number gets big and takes multiple rows. So in a second, I'm going to go ahead and stop this. Now, by the way, other programming languages would overflow at this point. They wouldn't allow numbers this big, but look how big. Let's look for the asterisk. There's the asterisk. Look how big our number got very, very quickly. And again, there's no way out of this loop. This would go on forever and continue to draw more and more resources from your computer. So there you go. So you've looked at while loops, you've looked at the iterator and the continuation condition, and we've also looked at the danger of loops and endless loops where the continuation condition is always true and the loop never ends.